Okay, today we are going to continue solving differential equation. So we have here another problem. Solve the differential equation below. So we're given quantity 2xy squared times dx plus quantity 2x squared y minus sine y dy equal to 0. So assuming that you have already tried the other method, you have tried testing this one for variable separable d, and then you find out that it's not possible, you cannot separate the variables, and you have tried the homogeneous, whether it's homogeneous or not, so that we can do the substitution, or you've tried linear first order DE and still it didn't work, and then you tried the you tried if it's a Bernoulli equation, you have checked whether it's a Bernoulli's equation or not, and then again it's not, then we have to find another way to solve it. And we have a topic we call exact differential equation. So we have to try whether it's exact or not. Okay? So actually this is a topic for exact differential equation. But we still need to check whether it's really exact or not. Okay, so to find out whether this is exact or not, then we have to find whether the partial derivative of, we have here the condition for exactness, partial derivative of m with respect to y equal to partial derivative of n with respect to x. So if we can prove that these two partial derivatives are equal, then we can say that this is an exact differential equation. Okay, so let's get back to the basic. So the given here, this is in the form of this one. This is a form of differential. Okay, so this part here, so this part, this is what we call partial derivative of f with respect to x, which is equal to m. Okay, and this part here, this is our partial derivative of f with respect to y, which is equal to n. So the exact differential equation takes the form m dx plus n dy equal to 0. Okay, so we have to test if we take the derivative of this m with respect to y and take the derivative of n with respect to x, if they give us the same result, so we can say that this is an exact differential equation. And then we have two steps to follow in finding the solution to this differential equation. And there are two methods, okay, two methods of solving differential equation that is exact. Okay, so the requirement here is, first you have to check. Now we have to check. This is your first step. Check if the given differential equation is exact. If the D is an exact D. So this is assuming that you have already tried the other methods and you failed to find the solution with those methods. then the next one is to determine whether this is an exact differential equation or not. Okay? So, if as mentioned here above, if the partial derivative of m with respect to y is equal to partial derivative of n with respect to x, then the given dA is exact. So if the given dA is exact, then we have step 1. We have here, take the partial derivative of m with respect to y. So if we take the partial derivative of m with respect to y, so we consider x as constant. Okay? So what is our m? Our m is this one. Okay? So our m is equal to 2x y squared. And then when you take the partial derivative of this with respect to y, so this will be, so x is constant, so we have to put the constant outside. 2 is a constant, so we have 2x, 2 is a constant, x is a constant, so we have to take the partial derivative of y squared with respect to y, which is equal to, so we have 2x, then partial derivative of this with respect to y, so that is 2y times dy over dy, right? Times derivative of u, or u here is y, so derivative of y with respect to y, so this one is equal to 1. So therefore, this is equal to 2x times 2y is equal to 4xy. Okay, so this is our partial derivative of m with respect to y. Then next, we have to find the derivative of, or partial derivative of n, sorry, this is n, partial derivative of n with respect to x. So what is our n? Our n is this one. Okay, so partial derivative of our n is 2x squared y minus sine y. Okay, so with respect to x. So if with respect to x, then y is constant. Okay, so what will happen? Y is constant, so we can take the partial derivative of this individually. Okay, so we have, so y constant, 2 is constant, so you put the constant outside. Okay, so we have 2, y is constant, so 2 times y times partial derivative of x squared with respect to x, then minus so this is constant, y is constant, so partial derivative of constant is equal to 0. Okay, so equal to, so we have 2 times y, then partial derivative of this, so our u is x to the power 2, so we have from differentiation, so 2x, then times the derivative of x with respect to x, where derivative of x with respect to x is equal to 1. So therefore, this is equal to 2y times 2x is equal to 4xy. So you see, we have two partial derivatives here that are equal. So therefore, so we'll say that since the partial derivative of m with respect to y is equal to partial derivative of n with respect to x, then the DE is exact. Okay, so our DE is exact. Okay, now if the DE is exact, what's the next thing that we have to do? Okay, so the second thing that we need to do is to find f. So let's find the function f, or f of function of two variables x and y. Okay, which is, if we take this m, okay, so such that this is the requirement, no? Find f, or f of x sub y, f of x and y, such that m equal to partial derivative of f with respect to x, and n equal to partial derivative of f with respect to y. Okay, so to do that, we have to integrate. So we have function of x and y equal to the integral of this. The integral of partial derivative of f with respect to x dx. So, by the way, this is just m. Okay, so this is our m, which is partial derivative of f with respect to x. So we integrate it. Again, as I mentioned, this is just equal to m, then times dx, which is equal to our m is equal to this one. So integral of 2x y squared dx. So with respect to x, then y is constant. Okay, so y is constant. So we can put the constant, which is y squared, and we have 2 is also a constant. So we have 2y squared integral of x dx, which is equal to 2y squared. So we apply here the power formula. Integral of, so what is the power formula? Power formula is if you have integral of u to the n equal to u to the n plus 1 divided by n plus 1 plus c. So we have to make use of that formula. Okay, so n here is 1, so this becomes x, 1 plus 1 is 2 divided by n plus 1, 2. Then plus, so instead of writing c, so we have to write here, our constant here is a function of y. So we have here f sub y. Okay, because you see, we are integrating the partial derivative of the function with respect to x, considering y is constant. So our constant here, c, instead of writing c, we have to write it as f sub y. Alright, so we have 2 at the numerator, 2 at the denominator, cancels out. So our f of x, or our f, is equal to x squared, y squared, rearranging, then plus f of y. So this is our function of the two variable x and y, which is equal to x squared, y squared, plus our constant, which is a function of y. Okay, or we can also say that we can write this as f is equal to x squared, y squared, plus f of y. So we can call this equation as our equation 2. Okay, so why 2? Where is 1? So our equation 1, we have to consider this as our equation 1. Okay, this part here. This part here, let's consider this as our equation 1. Okay, so in solving the solution of this differential equation, we have two methods. So method number 1. Okay, so we have method number 1. Or method 1. Okay, so we have to take the partial derivative of this f. Okay, so taking the partial derivative of this f with respect to y. So partial derivative of f with respect to y equal to partial derivative of the whole thing, this one. X squared, y squared, plus f sub y, then with respect to y. Okay, so with respect to y means our x is constant. So we hold x as constant. So what's the result? This will be, do it individually. Okay, we'll just go directly now. So we have x is constant. So we have x squared. Okay, then take the derivative of y squared with respect to y. So that is 2y times our u here is y, then n. So this is the same as derivative. We use the formula here, derivative of u to the n with respect to y equal to n times u to the n minus 1. Okay, so we have to use that formula. So this becomes 2y times the derivative of y with respect to y, which is this part here is just equal to 1. Okay, plus, so taking derivative f of y, so this will be f prime of y. Okay, so our partial derivative of f with respect to y is equal to, rearranging, so we have 2x squared y, then plus f prime of y. So let's call this equation as our equation 3. Okay, now if you look at equation 3, so take note that this equation 1 is, this is our partial derivative of f with respect to y. Okay, and then we have partial derivative of f with respect to y. So we can equate this to equation. So we can say equating equation 3 and 1. So we equate the two equations. So let's write first the third equation, which is the right side of this, which is 2x squared y, then plus f prime of y. Okay, this is the right side of equation 3, equal to, we have also another partial derivative of f with respect to y in equation 1, all right, which is equal to this. We have 2x squared y, then minus sine of y. Okay, so we'll just take this, dy is not included because this is n, di ba? This is n, which is equal to partial derivative f with respect to y. So exclude this dy. Okay, so if you look at the equation, on both sides there is a common. So we have here, this term here appears also on the right side. So we can just cancel them. Or if we subtract both sides by this, then what is left on the left side is only f prime of y equal to minus sine y. Okay? So next we have to integrate both sides. Okay, I'll make use of another paper. Okay, so from our last equation, okay, I'll just rewrite this one. So we have f prime of y is equal to minus sine y. Okay, so the next step that we are going to do is to integrate both sides of this equation. So integrating both sides. Okay, so we have f prime of y, the other one is minus sine y. So when you integrate this, okay, so we have to put dy. Okay, so the integral of f prime, so this is f prime is just like dy over dx. Okay, this is just the reverse or inverse process of the integration. This is differentiation integration. So what will be left here on the left side becomes just f when you integrate this. So this will be f of y equal to, so we have to use the formula of the integral of sine u du is equal to minus cosine u plus c. Okay, so we can call that as c. Then we have here, you can put the integrals, the negative sign outside the integral sign, then you integrate. So we have negative integral of sine y dy, which is equal to negative, we have negative, and then this is also negative, so negative cosine, our u is y, so derivative of u, which is derivative of y, is just dy, so this is cosine y. Okay, and then we add the constant integration, we call that constant as c1. Okay, so f of y is equal to negative times negative equal to positive cosine y plus c1. And take note that this, okay, let's call this equation first as equation 4. Okay, and then let's substitute this equation in our equation 2. Okay, in equation 2 we have f, we'll say for your guide, no, we have to substitute 4, equation 4 in equation 2. Our equation 2 is this one. Okay, this is our equation 2. So substituting it there, we have f equal to x squared times y squared plus our f of y is simply cosine y plus c1. Okay, and take note that this is equated to 0, so equal to 0, so x squared y squared plus cosine y, then equal to, you transpose this to the other side, so this becomes minus 1, then we let c equal to c1, sorry, negative c1, we let c equal to negative c1, so therefore we have x squared y squared plus cosine y equal to C. Okay, so this is our equation. Okay, now if for example the problem gives us initial condition. Okay, so let's add something here. Assuming that the problems give us initial conditions, say if the initial condition is something like this. Y square root of 2 over pi equal to pi, something like that. So we have in our algebra or in our differential calculus, we have this y equal to f of x. So therefore, this form, this is actually our x and this is our y value. Okay, so if you are given this kind of condition, then we can substitute that given to solve for the constant. Okay, the purpose is to solve for the constant c. Okay, so assuming now we are asked or we are given this initially, this condition. Okay, so let's put it here that we have y square root of 2 over pi equal to pi. So as I mentioned a while ago, this is our x, this value is our x, and this value is our y. So substituting this to this equation, then we can solve for the constant. Okay, so let's substitute. We have our x is square root of 2 divided by pi, then this is square, so square this, then y is equal to pi, so pi squared plus cosine of y, where y is equal to pi, okay, then equal to c. So from the law of exponents, we can rewrite this as 2 over pi squared, okay, then times pi squared, then plus what is cosine of pi. What is cosine of pi? Cosine of pi is equal to, what's the cosine of pi? Cosine of pi is equal to 1. Okay, so this is cosine of pi is equal to minus 1 equal to c. So we have pi squared at the denominator, pi squared at the numerator, so cancels out. So we have 2 minus 1 equal to c. So 2 minus 1 is 1 equal to c. So therefore, our solution, a particular solution is x squared times y squared plus cosine y, then equal to 1. Okay, so this is our first method in finding the solution. So for the second method, I will do it in another video because it's very long already. Okay, thank you very much. If you have any question, you may leave your question or your comments in the comment section below. Thank you.